Hey guys, welcome to another episode of MrLopezClasses.com. This is the chapter 3, episode 2, related with diesel engines. We are going to start to talk about diesel engines. The concept of the diesel engine, what is the difference with gasoline, and what happened internally in a diesel engine. For what reason the name diesel. Alright, but before of that, I want to explain to you what is the function of an engine. What is an engine? I want here from yours different definitions of an engine. I think a good definition of an engine is an equipment designed, of course, to produce output torque, and is an equipment designed to burn air. The majority of the people, they say, no, that motor burn fuel. No. The engine burn air. Oh, Mr. Lopez, but my engine is gasoline. Yes, that engine uses the gasoline to burn air. Oh, that engine is propane. That engine uses the propane to burn air. The diesel engine uses the diesel to burn air. Those are the fuels in order to burn air. What engine is more efficient? The engine that burn more air with less fuel. What engine is more efficient? The engine that burn more air with less amount of fuel. The diesel engines are the more efficient. Because in a diesel engine, you can introduce the maximum amount of air with the turbos or superchargers, and with a small amount of fuel, burn more air and produce more torque. That's the reason. Okay. The engine is an equipment designed to burn air, no fuel, air. The fuel is used to ignite the explosion, to produce the explosion. All right, let me check the difference in between gas and diesel. Right now, later in this episode, we are going to talk about the strokes. Oh, my engine is 2 strokes. Oh, my engine is 4 strokes. And I am going to explain the difference between 2 strokes and 4 strokes. Yeah, and we are going to check a 2-stroke gasoline and 4-stroke gasoline, and 2-stroke diesel and 4-stroke diesel. Both of them. We are going to talk about both of those engines at the same time. All right, my friends? Okay, let me explain something about that. In general terms, later, in a couple of minutes, we are going to talk about the stroke, but right now, only to understand the main difference in between the gas engine and the diesel engine. Let me explain something. In a gas engine, in a gasoline engine, when the piston is in the maximum point of compression or top dead center, we are going to talk later. When the piston is in the maximum point of compression with the valves closed, the gasoline engine compresses the mixture air and fuel, air and gasoline. And when the air and the gasoline is fully compressed, in that moment, the spark plug produces a small spark, and the spark ignites the fuel and sends the piston down and start the cycle. This is in gas. Once again, the piston goes down, the intake valve is open, and enter air and fuel, air and gasoline, in gasoline, air and fuel. And after that, the piston goes up, the valves close, and the piston compress the mixture. When the mixture is fully compressed, the spark plug ignites the mixture and produce the explosion, and the piston boom goes down at higher speed and continue the cycle. This is in gasoline. That's clear, my friends? All right. In diesel, When the piston is going down, 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 with the intake valve open, only suction air, pure air, and suction air, 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 and close the valves. When the valves are closed, the piston goes up. And compressed, pure air, 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 air. When the air is full compressed, pure air, the injector open, no spark plug. The injector open and inject, spray, atomize a little amount of fuel. And that small of fuel, because the air is at high temperature and high pressure, the temperature is around 1075 degrees Fahrenheit, and the pressure is superior than 600 psi. At that excessive amount of pressure and temperature, when the fuel enters atomized, produce the explosion and the piston goes down. Boom! This is only possible with diesel. If you have air full compressed and you introduce gasoline, the gasoline ignite. If you have air full compressed at that temperature and that pressure and you introduce propane, the propane explodes? No. No, only diesel. Only diesel have that property. Oh, what happened? No, in the other one, the propane, the alcohol, the gasoline ignite because the spark produce the spark and produce ignite the mixture. Because the spark. In this one, we don't have a spark. Only because the air is full compressed when the fuel enter atomized in that area full compressed, the fuel ignite and produce a big explosion and the piston goes down. The explosion here in the diesel engines is 10, 20, 100 times the explosion in any other type of engine, gas, alcohol, propane. For that reason, when the piston goes down in a diesel engine, produces a torque 3 times, 4 times the torque produces for the gasoline. And of course, more horsepower and more and more and more efficient. Yes. Once again, if you compress pure air, you can reach temperatures around 1000 degrees Fahrenheit or more. If you compress air mixed with other fuel, you reach temperatures around 200 degrees Fahrenheit, 300 degrees Fahrenheit. When you compress pure air, you have those temperatures and pressures superior to 400, 600, 1000 or more psi. In a gasoline engine, when you compress air with gasoline or other fuel, the pressure is around 200 psi. Of course, the power of the detonation in this engine is superior than the power of detonation in the other engine. That's the main difference. All right? Clear? What is the main difference in between a gas engine and a diesel engine? The majority of the people respond, oh, because the gas engine ignite gasoline and burn gasoline and the diesel engine burn diesel. No. Both engines burn air. Oh, the diesel engine to burn the air use diesel. The gasoline engine to burn the air use gasoline. Okay, no, this is not the difference. The difference is in a diesel engine to burn the air, the detonation is produced only because the air at high pressure and temperature, when the fuel enters, is ignite and produce that explosion. In other words, in the ignition of the diesel engine, you only need air full compressed. In the ignition of a gasoline engine, you need the mixture compressed and you need a spark. In this engine, you don't need a spark. Yes, in a diesel engine, you don't have spark plugs. Yes, in a diesel engine, you don't have cables for spark plugs. You don't have distributor. You don't have ignition coil. You don't have that complicated electronic system, the ignition system. In a diesel engine, you only need that one injector open and spray fuel. That's it. For that reason, the diagnosis of a diesel engine is too simple. For that reason, the troubleshooting in diesel engines is too simple in comparison with gasoline. That's clear, my friends? That's the main difference between a diesel engine and a gasoline engine. Later, in the chapter dedicated to the fuel systems, we are going to talk about the efficiency, and I am going to explain why the people say too much blah 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 in relation with the diesel engines. Oh, the pollution in the world is basically because the diesel engines. It's not because the diesel engines. It's because the quality of the fuel, because the quality of the diesel produced in different countries. In the majority of the countries, the quality of the diesel is bad quality. I'm going to explain later in other chapter, the chapter dedicated to fuel systems. Okay, my friends. Until this point, is clear the main difference between gas engines and diesel engines? Okay, great. All right, we are going to check what is the theory related with this. A diesel engine is an internal combustion engine, of course, that use the heat of compression to start the ignition to burn the fuel which is injected into the combustion chamber during the final stage of the compression. Yeah, it's a good definition. But in the diesel engine, you need the air full compressed. In this moment, in this combustion chamber, when the piston is finishing the compression stroke, you have pure air. Immediately the piston finishes the trouble, the injector sprays the fuel, and the ignition is produced. You don't need a spark plug. Oh, Mr. Lopez, what about the glove plugs? The glove plugs is an element to preheat that area. This is commonly used in older engines and is commonly used in cold areas at low temperatures in order to preheat the head and preheat that area in the combustion chamber. We are going to talk later. The glove plug, this element, the glove plug, is not a spark plug. No. The glove plug no produces spark. The glove plug only produces a high temperature and preheat that area. For that reason, the other name for the glove plug is preheater. Preheater. That's the other name. All right, but we are going to talk later about that. And this picture is excellent because it's a great comparison in between the gas engine. In the gas engine, you have this element, the spark plug. The rest of the engine is pretty similar. You have an intake valve, you have a exhaust valves. Indeed, you have intake valves, exhaust valves. But in this one, you have a spark plug. In the second one, you have the injector. Mr. Lopez, but in the gasoline, I have inject. Yes. The new engines, they have a spark plug and injector. If you check the head in a top view, you have intake valve, you have exhaust valve, you have one hole for the spark plug, and you have another hole here for the injector. But in a diesel engine, if you check the head on a top view, you have both valves and you have one hole for the injector. That's it. You don't have a spark plug. This is the diesel head, and this is the gas head. All right? All right, my friends. That's the main difference between gas and diesel. And we are going to study in diesel engines different systems. We are going to study the fuel system, the intake system, the exhaust system, the lubrication system, the cooling system, the ignition system. And we are going to study in details, chapter by chapter, those systems, the different type of fuel, the different type of cooling system. I am going to pass quickly those slides because I am going to explain in details each of those systems. All right, my friend. And now we are going to talk about the efficiency that I explained to yours, that the diesel engine is superior in efficiency in comparison with the other internal combustion engines like propane engines, alcohol engines, methanol engines, gasoline engines. The diesel engines is superior in comparison in terms of efficiency. Diesel engines have the highest thermal efficiency of any internal or external combustion engines because of their compression ratio. Low speed diesel engines, the thermal efficiency is superior to 50%. It's superior. It's more than 70, more than 80. Is high efficient engines. All right, diesel engines are manufactured in 2 strokes and 4 strokes. There are 2 versions of 2 strokes and 4 strokes. Okay, in order to understand easily that situation, I am going to explain what is the difference between 2 strokes and 4 strokes. And right now, I am going to start with the explanation of 4 strokes. Okay, guys, in order to understand the 4 strokes, I prepared this slide. This slide is this is the block. This is the block. This is the head. The piston is moving up and down, and the crankshaft is rotating. In this particular example, we are going to suppose that it's rotating clockwise. All right, and those are the intake valves, and those are the exhaust valves. And I prepared this table. In the table, I put the typical 4 strokes that you hear: intake, compression, power, and exhaust. Intake, compression, power, and exhaust. Those are the typical 4 strokes. And we are going to understand what is the meaning of that. What is the meaning of intake, compression, power, and exhaust? All right. I need that you follow me. And at the same time, follow the table that we are going to fill in order to understand what is the meaning of 4 strokes. And after that, with the same concept, I am going to explain what is the meaning of 2 strokes for gas and diesel. All right. All right, my friends. Suppose that this is the head. This is the head. My hand is the head. And this is the piston. And in the head, I have 2 valves. I have intake valves and exhaust valves here. Intake valves and exhaust valves. Those valves that you have here on the screen, intake and exhaust. And this is the piston. All right, suppose that I am going to start with the intake. When the piston is going down. Okay, let me check. In the intake, the piston is going down. Ready? Perfect. The piston is going down. Now, when the piston is going down, I want to enter air in the diesel engine or air and fuel in the gas engine. Ready? Okay. In that case, when during the intake stroke, the piston is going down, and what valve is open? Intake valve or exhaust valve? Intake valve is open and exhaust is closed. Okay. During the intake valve is open and the exhaust valve is closed. Perfect. And the piston is going down. And the crankshaft, in this movement, the crankshaft rotates half turn. The crankshaft rotates 180 degrees, half turn. All right, perfect. And now the piston is in the bottom. And the piston starts to go up to produce compression. What happened with the valves in order to compress? Should be both of them closed. Okay. Close and close in compression. The piston is going up. The piston is going up. And the crankshaft rotates other 180 degrees. Other 180 up. Right now, the piston is at the end, on top that center when both valves are closed, and the piston on top. Ready? And now the fuel enter in diesel engines and produce the explosion, or the spark plug produce the spark and ignite the mixture. Okay. In this moment, the power is produced, the explosion is produced, and the piston goes down. What happened with the valves? The valves open or close? the valves continue closed, but the explosion is produced. Okay, in power, the piston goes down again. The explosion sends the piston down. Other half rotation of the crankshaft. Other half rotation of the crankshaft. And the piston, the valves close and close. And now the piston is in the bottom again, and all of this cylinder full of smoke. And right now the piston try to goes up again, and what happened with the valves? Intake and exhaust. Intake stay closed and exhaust open, and the smoke goes out. This is exhaust. All right, the piston is going up. The crankshaft rotate other 180, and the valves intake closed and exhaust open. Bingo. Those are the 4 strokes. Those are the 4 strokes. Intake with both one valve open, intake valve, and right now compression, both valves closed, piston goes up, and now explosion, piston goes down with the valves closed, smoke, and now exhaust valve open and the piston goes up, exhaust. Oh, nice. During that process, intake, compression, power, and exhaust, how many revolutions complete the crankshaft? Half, 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 and half. 2 revolutions of the crankshaft. Nice. In order to produce the 4 strokes, the crankshaft rotates 2 times, 2 revolutions. This is the 4-stroke engine, my friends. Now you understand what is the meaning of 4 strokes. And what is the relation in between the piston, the valves, the movement of the piston, the movement of the valves for 4 strokes or 2 strokes. You like it? This is the process. This is the process to produce 4 strokes. And now I am going to explain the same procedure for 2 strokes, gasoline and diesel. But before of that, let me review quickly the theory that I have in the book. Diesel engines are manufactured in 2 strokes and 4 strokes. Yes, in this particular example, let me I refresh intake. The intake valve is open. You see the smoke enter, the air enter in the combustion chamber. The exhaust valve is closed. The crankshaft is rotating half, and the piston is going down. Okay, in compression, the piston is going up. Both valves are closed. The valves continue closed, and the piston is going down in combustion or power. And after that, in exhaust, the piston is going up, the exhaust valve open. This is a perfect picture about the 4 strokes. And this is another example about the 2-stroke that right now we are going to talk about 2-stroke. All right, this is 4 strokes, this is 2-stroke, but let me 1 second before I explain 2-stroke, because there are 2-stroke gasoline engines and 2-stroke diesel engines, and there are a lot of difference between both of them. Okay, let me check what happened in the combustion chamber of a diesel engines during the 4 strokes. What happened? What is the temperature? What is the pressure? The high compressor hit the air in diesel engines around 1020 to 25, 75 maximum degrees Fahrenheit. Depending of the manufacturer, depending of the compression, depending of the seal of the rings on the piston, if the combustion chamber is hermetic, the temperature is higher. This is critical. My friends, in order to ignite the diesel, it's necessary that the temperature in the combustion chamber will be at a specific temperature and the pressure. If not, the diesel not ignite, and the fuel pass directly outside through the exhaust pipe. What is the minimum temperature? We are going to talk later. It's around 700 degrees Fahrenheit. This is the minimum temperature in order to ignite the fuel, and also with the pressure. We are going to talk later about that point. But in normal conditions, the temperature in the combustion chamber is around 1000 degrees Fahrenheit in normal conditions. This is the moment where the fuel is injected directly into the compressed air and inside of the combustion chamber. All right, this is the situation in the combustion chamber, and normally the temperature should be around 1025, 1075. This is one of the ABYC questions in your exam. Two-stroke engines. In this section, I am going to explain the main difference between two-stroke gasoline engines and two-stroke diesel engines. We are going to start with the explanation related with two-stroke gasoline engines. And after that, I'm going to explain in diesel engines what is the situation and what is the difference between both engines. Yes, in marine applications, there are inboard engines, diesel engines, two-stroke engines. There are a couple of manufacturers. Detroit Diesel is one of those manufacturers that fabricate inboard engines with the two-stroke engines. Those engines are special engines with excellent efficiency. Those engines produce higher torque in comparison with the four-stroke engines. And there are some advantages of those engines and some disadvantages. In general terms, the people prefer every day use more and more the four-stroke engines, basically because it's less noise, and less contamination. But in other scenarios, especially in outboards, the manufacturers fabricate a lot of two-stroke engines. All right, two-stroke engine is a combustion engine that completes the cycle in 2 movements of the pistons, in comparison with the 4 movement of the piston of 4 strokes. You remember, in 4 strokes, during the intake, the piston goes down, 1 movement. During the compression, the piston goes up, 2nd movement. During the power, piston once again goes down, 3rd movement. And during the exhaust, piston once again goes up, 4th movement. 1, 2, 3, 4 movements to complete 1 cycle, to complete the cycle of intake, compression, power, and exhaust. In those 4 movements, the crankshaft rotates 2 times. This is for 4-stroke engines. In 2-stroke engines, when the piston is going down, occur intake and exhaust at the same time. And when the piston is going up, occur power and exhaust, power and compression. Yeah, 2 strokes in each movement. For that reason, the name of that process is a 2-stroke engines. All right, right now I am going to explain quickly what is the main difference between both type of engines. But in order to understand easily the 2-stroke gasoline and 4 strokes, let me explain something about that. If you remember, in a 4-stroke gasoline engine, we have the head, and in each side of the head you have an exhaust manifold and intake manifold. This is the intake manifold. And on the intake manifold, you have the throttle body or carburetor, and on top you have the air filter. That's the air filter. This is for 4-stroke gasoline engines, or diesel is similar. All right. For 2 strokes, and remember, in 4-stroke you have the valves located on the head, the intake and the exhaust valves located on the head. And the camshaft is connected with the crankshaft by means of the timing chain. Right? This is in 4 strokes. In 2 strokes, what happened in 2 strokes? In 2 strokes, there are some difference. For example, in 2 strokes, the cylinder is not a cylindrical element like this. The cylinder have a couple of holes, one in each side, 2 holes, one in front of the other one, like the picture that you have on the screen right now. In the bottom of the cylinder, if you check in the picture, there are 2 holes, one practically in front of the other one. And additionally, the shape of the piston, the head of the piston in 2-stroke engines have this shape, like a castle, like this. And what is the idea? In the bottom of the cylinder, there are the holes. One hole here, and other hole in the other side for exhaust, because the exhaust manifold is located here in the other side for exhaust. Yeah, one of the difference. If you check for visual inspection, the two-stroke engines have the input of the mixture and the output of the gases in the bottom of the block, not on top. In a four-stroke engines, the intake and the exhaust manifolds are located on the head, in each side of the head, like the picture that you have on the screen right now. This is in four-stroke. In two-stroke is in the bottom of the block, because in this particular case, this is the intake manifold. This is the intake manifold, and in the intake manifold you have here the carburetor or throttle body, and the carburetor mixed the fuel and mixed the oil and mixed the air. You have fuel plus oil plus air entering in the combustion chamber in the bottom. Yeah, for one side of the holes. In the other side you have the exhaust. Let me show to you. This is the situation, exactly the situation. This is the block, and this is the head. The head only have the hole for the spark plug. Yeah, and on the cylinder you have one hole here for intake, and you have other hole here for exhaust. Let me check what happened. And in the bottom, in the crankcase, when you talk about the two cycle cylinders or two-stroke engines, the name of the oil pump is the crankcase. The crankcase and the block, this is the bottom of the engine. In the bottom of the engine, in the crankcase, this is the crankcase. In the bottom of the crankcase is where the oil pan is together with the block. There are one port with a valve, like a check valve. That port allow, this is the carburetor with the air filter, with the fuel tank, and other tank here for oil. All right, this element, this carburetor mixed the fuel, the oil, and the air, and in the crankcase enter all of those elements: fuel, air, and oil. And when in between the cylinder wall and the piston, the mixture goes up. The mixture goes up here and enter in the combustion chamber when the piston reaches the bottom, and this hole is in front of the other hole. In other words, in that moment when the piston is in the bottom dead center, BDC, in the bottom, the mixture, the fresh mixture, enter here with high pressure and push the smoke out, and the smoke goes out. The name of that process is scavenging. What is the meaning of scavenging? Is the cleaning of the combustion chamber when the piston reaches the bottom dead center, and the fresh mixture enter for one port and push the smoke in the other port. This is the scavenging, and occur in two-stroke engines. We are going to study later in four strokes. We have a scavenging. It's a little different, but we are going to study later that phenomenon in diesel engines. Right now we are talking in this moment about the two-stroke gasoline engines. All right, the mixture here, this is the fresh mixture. This is the fresh mixture. Enter and push the smoke, the gases, out. The name of that process is scavenging. This is when the piston is going down. What happens when the piston is going Yeah, this is the process when the piston is going down. When the piston when the piston is going up, the mixture is compressed, and at the same time, the spark plug produces the spark and ignite the mixture, air, fuel, and oil. And immediately the piston goes down at high speed and high force. And once again, when the piston reaches this portion, once again the mixture enter and push the smoke out. It's clear? When the piston is going down, and reach the bottom, the fresh mixture enter and push the smoke out, because both ports are one in front of the other one. And right now, when the piston tries to reach up, close this port and close the other port and compress the mixture. And just before the piston reach the top of the center, the spark plug produces the explosion and the piston goes down immediately and the cycle continues. In other words, in a two-stroke gasoline engines, intake and exhaust occur in one direction and compression and power in the other direction. Two strokes, two movements. This is the gasoline two-stroke engines. What is the inconvenience? When the fresh mixture enters here, not all the smoke goes out, and you have pollution. For that reason, the motorcycle two cycles, the smoke and the sound, too much sound. All right, how the sound can be reduced with the exhaust pipe. Depending on the design of the exhaust pipe, the sound is reduced, but the two-stroke engines produce a lot of noise, and this is one of the inconvenience. And other of the inconvenience is the smoke and the gases produced outside. All right, this is two-stroke gasoline engines. In the class of gasoline, I am going to repeat this explanation with more details. All right, and now we are going to talk about the two-stroke diesel engines. If you check in this picture, once again, in the bottom of the cylinder, two-stroke diesel, there are holes, like the cylinder that you have on the screen right now. Those holes are excellent for the intrusion of air, pure air. And how the air enter in the bottom? In this particular case, it's not like in the previous one, gasoline two-stroke that only for atmospheric pressure enter. In this particular case, there is located this element. This element is the supercharger or blower. The blower suction the air. This is the air filter, and suction the air and enter the air with high pressure and high speed in the bottom of the cylinder. And right now the air enter here, and in the moment that the air is entering, because the piston reached the bottom depth center, the piston reached the bottom, in the moment that the piston reached the bottom, immediately the exhaust valve open. Yes, the diesel engines two strokes, they only have exhaust valves. No intake valves. All right, that's very important. In the previous gasoline, they don't have any valves, no exhaust, no intake. Oh yeah, of course, the two-stroke gasoline engines, they don't have a camshaft, and they don't have timing gear. No, they only have the crankshaft to move the pistons and one spark plug on top. Two-stroke gasoline. Right now, in diesel, in the two-stroke diesel, on the head we have exhaust valves to release the smoke, and we have injectors. We don't have a spark plug. Injector because it's diesel. All right, and what is the idea? When the piston reaches the bottom depth center, this is the bottom depth center, BDC. When the piston reaches the bottom, immediately through this port, enter fresh air, and the fresh air pushes the smoke out, and the smoke goes out here to the exhaust. This is the exhaust manifold. All right, and this is the crankshaft. and the crankshaft, the gear of the crankshaft engage with the gear of the camshaft. This is the timing position, and the camshaft, those are the lows of the camshafts, move the push rods, and the push rods activate the rocker arm, and the rocker arm open or close the valves. This is the typical diesel engine, two-stroke engines. Yes, in the diesel engine, you have oil in the oil pan, in the crankcase. You have oil, and you have this stick in order to check the level of the oil. In the gasoline two-stroke engines, you don't have this stick. Why? Because you don't have in the oil pan oil accumulated. Remember, the carburetor in two-stroke gasoline engines mixes the oil with the air and the fuel, and that mixture enters in the crankcase, and when the piston goes up, suction that mixture and enter in the intake port. That's gasoline. In diesel, the diesel engine have in the bottom oil dedicated, and you have dipstick to check the level of the oil. And you have valves in a two-stroke diesel engine. Yes, you have only exhaust valves, only exhaust valves. And you have of course, you have the gear for the camshaft. You have camshaft and you have crankshaft. All right, and I am going to repeat the procedure. When the piston is going down, two-stroke diesel engine, when the piston reaches the bottom depth center, when the piston reaches the bottom dead center, this port is open, and the air coming from the turbocharger or supercharger, the fresh air, enter directly through the holes and fill the cylinder. When the fresh air enter and fill the cylinder, the smoke is going out because the exhaust valve is open. Immediately the piston reaches the bottom, the exhaust valve open, and the gases goes here and goes out, and bye-bye to the exhaust pipe. All right? And after that, the piston start to goes up. When the piston is pretty close to the top dead center on top, the air is full compressed, only air, and immediately the injector open and spray the fuel, and the fuel ignite the air, and the explosion is produced, and once again the piston is going down. All right, it's very simple. The two-stroke diesel engine only have exhaust valves, only have injectors on the head, and the input of fresh air is in the bottom, in one side of the block, where the blower or supercharger is located. The air enter in the bottom. When the piston reaches the bottom of the center, those holes are open and the air enter over there. Immediately the fresh air enter in the cylinder, push the smoke out, and the gases goes out, and the cycle continue and continue and continue. What is the advantage of those diesel engines, two-stroke diesel engines? The advantage is that those engines, two-stroke, produce higher torque than the four-stroke engines. Higher torque. Those engines, two-stroke diesel engines, are very, very, very common in mega yachts, in cargo boats, in cargo ships, because those engines produce excessive amount of torque, and they work at lower RPMs than the four-stroke engines. For that reason, are the preferred engines for cargo ships, for containers, and mega yachts. This is the basic difference between two-stroke diesel engines and gasoline engines.